Well, I got the filter capacitors in here on a terminal strip, and there's a resistor that went from the positive of this capacitor to the 10 microfarad positive. I got that in back. Had to create the value because they don't make those same values anymore. Well, we got it, and we're well within the original 20% of the one back there, which I just left there. So basically the two cans on top of the circuit board are disconnected. I did reroute one wire, and that was this green wire. It went with the white wire up here, but it was no longer long enough to reach there. So I just connected it to the white wire over here, which is just as good. All the hot wires are coming down. The red wire coming from the rectifier tube was too short, so I put in a brand new cloth covered wire there. And I just didn't have a green one to replace that green one with the same kind of wire, so I didn't want to do that. I also wanted to make sure that all the wires were rerouted down in the power section here, and that nothing was going up to cause interference up higher in the amplifier circuit. Okay, that said, I did find a couple issues. Somebody has worked on this radio before. I don't know when, I don't know what they did. But the other thing I did find was this burnt resistor here. You see, there ain't nothing left to it. It's just a piece of a resistor on a lead. Why that's still there, I don't know. I tried to find the other half of it, and I don't see it anywhere. I don't see any loose leads. I don't see any pieces of a resistor on a lead. I don't see any of that. I see a sprayed capacitor here, which doesn't match the rest of the capacitors, so I don't think it's original. This resistor looks suspicious. It's very dangly. I don't think Philco would do that. And there's other issues that I'll show you in a second that are the same. This resistor looks more original, probably made a short connection over to there. And that's possible, and it burnt out. And so they put a bigger resistor in. I hope that's not the case, because if they replace this little 1 quarter watt resistor with a 2 watt resistor, that's not the way you fix a shorted out resistor. If there's a resistor that's burnt, there's a reason for it. You don't increase the wattage of the resistor, so it's like putting a big fuse in a small fuse box, right? You don't do that. It's a safety risk. The reason that the resistor burnt out is there was a problem. So I got to do a little bit of tracing before I power this unit up. A couple other issues I seen was this doesn't look original here. This is a cloth covered shielded wire. It may be original. It probably is. There's another one here. But this just looks really suspicious. I can't picture Philco doing that, cutting the lead short, putting a braid on the socket on the circuit board down there, and that lump of solder just doesn't look good. And then soldering them together. I mean, there's nothing wrong with the connection. There's nothing that will work, but it's just not professional looking. Here we have a capacitor that looks like it was replaced or cut off and then resoldered, and you see it's got a clump of solder here, and then it looks like it might be J-hooked there. So this might be a replacement one. It is a sprague like the ones around it, so I don't know. It might be that this radio was recapped at one time, but I kind of doubt it. These are old sprague capacitors. The only ones that look suspicious is this black bumblebee. Of course, it's got to go, and it will go. And this one looks a little bit suspicious. This is an electrolytic 5 microfarad. I don't remember seeing no 5 microfarad on the schematic, and I don't know what it's doing. So I got to check that out. Look at this. Can you believe that? Take a closer look at that. There's a big resistor flopping around on leads on the output tube and right up against the chassis. And if anything's going to burn something out, that would do it. Here's a wire that's just sticking up here with no information as to where it goes, what it does. In fact, it looks like it was a component that probably burnt off too. It could be another resistor, and they replaced it with this carbon resistor. I don't know, but I know Philco didn't do this. They wouldn't leave leads that long. You see how that was right up against the chassis? Big problem. Here we have another capacitor that's J-hooked in. See here? That's not original, at least not that way. And again, big old floppy leads, big old floppy lead here. You know, that's not the way those would have been done. They would have been very, lead lengths would have been right. This one going to the chassis looks suspicious, but it's probably fine. This is fine, this is fine. Well, anyway, we got the new capacitors, electrolytics in, so now I can bring it up on the variac slowly and we can see if we can get any kind of sound out of it before I go recapping everything. But before I do that, I want to verify this resistor. Oh, look at that, it ain't even soldered good. Look at that, it just came right off. It was just like touched on there with solder. It wasn't even wrapped around or anything. And I found other wires that were like that, that I've worked on already. So these may not even be J-hooked, that may just be soldered. And you don't solder that way. First off, you see what happens. It was a cold solder joint. It didn't even stick. Secondly, it's not hooked, so it ain't even a mechanical connection. And that's a big no-no. But I'm just going to tack it there so we can do a test because I'll change it anyway. Also, I noticed this is broken out. Came out of this socket here. Let's see if I get that right in there. See that connector? This connector was inside, slides inside of there, and somebody took it off and soldered a wire in this capacitor onto it. And of course, when they took it out, it looks like they kind of gummed up the connection there, so this won't go back. I don't know what that was for. Probably an outside antenna. Well, it ain't going to be an outside antenna sitting around like that. It's just useless. So whoever's worked on it was definitely sloppy. There's another line that's just tacked to another one. You see that down in there? And look at this wire. Let me get a little pointer here. Put a light a little closer. Look at this resistor wire right up against this bad solder joint. And this is going to a capacitor. So they don't go to the same place, so they're not supposed to be touching. That is just tacky. That's tacky. You don't do stuff like that. You don't do stuff like this. You don't leave pieces of things dangling around like they're antennas to pick up noise. I don't know if what they did was good. I don't know. I don't have time to go checking every single little thing that somebody's done. All I can do is troubleshoot any problems that come along. I will troubleshoot certain things. And of course, most of this will be replaced anyway. Once I go around changing these capacitors, take these big old boys out and put in the smaller, newer ones. When I take these big old boys out, I can see what's going on. But I definitely want to verify this strange thing with this long lead coming from here, 5 microfarad, going over to this tacky connection, to this tacky resistor, and see if that's even correct. Because like I said, that makes no sense. Well, this is, I'm sorry, this is a 0.05 going there, but that's a bad job. This is the 5, that makes no sense. It's a dry electrolytic, 50 volts. So I don't know what's going on there. But let me go ahead and tap this back on, take a look at the schematic, and make sure that everything I can see is right before I give this power. But we'll have it on a current limiting device, so it'll be fine anyway. Let me check it out, and we will continue. I'll let you know what I find out. Okay, this one I burnt up here, this little 1 watt, well, actually a 1/4 watt. Could have been a 1/2 watt, but I don't think so. I think it's just a 1/4 watt carbon they replaced with this, which is either a 1 or a 2. I think it's a 1 watt now that I look at it. Actually, this would be a 1/2 watt, because that's a 1/2 watt, and that's a 1/4 watt. Yeah, so this is a 1/2 watt. They replaced it with a 1 watt. All right, that was a mistake, but they did it anyway. This was obviously burnt, which comes off the B+, comes right off the B+, and goes to an IF can of all things. Oh, geez, I hope they didn't fry that IF can. But fortunately, they probably didn't hurt it because they put up a very high value resistor. This is a 47. Oh, I take it down back. They dropped it down. This is not an orange, that's a brown. This is 470 ohms. They dropped this from 1,000 ohms to 470 ohms going to the transformer, the red line to the transformer. So if you look at the schematic, here's the red line of the transformer going to T5, and see it's red here, and it goes through 1,000 ohm R17, and then through C37, which is a 0.05 microfarad to ground. So R17 is 1,000 ohms, and that goes to this red wire going up to T5 and 6. Now, actually, if I go to the bottom view here, there it is, R17 and C62. Those are the two. And they come off this strip. You see this angled strip here. And here's the 7H7 tube, which is between the two IF cans. There's a can here and a can down here. Well, anyway, you can see that there's a strip here at an angle, a strip there, and those are two on that side. So R17 and C64. If you come back to the schematic, this is R17, and this is C37, 0.05 microfarad. But the one that was right next to it is C64, C64 two, I'm sorry, C62, which is off the main power, right? It's in parallel with the with these two electrolytics. Well, it's in parallel with this one, and it's across the resistor to this one. But that's it. And so there's the C62, and here is the R17. Well, if you come the other way, if you come here, this is hot. Okay, yeah, that goes to the R16. All right. Well, anyway, they're just laying next to each other here. They don't go to the same places. They don't connect to the same place. They're just laying side by side. And this C62 is this one here, which is a 510 picofarad, and that's what that is. You see the green, that's the 5, and I can't see the rest of it, but that's it. And the one that it's next to is R17, which is not connected to it. It's connected through this 8200 ohm resistor. So here it is here, R17. Now R17 also connects to C37, which goes to ground. If you come back here, you'll see C37 is right here. So this resistor connects to this one. This resistor is a 1000 ohm. This is 0.05 or whatever it is. So here it is, connecting here, and it also connects to this 0.01 to ground. So it connects to the 0.01 to ground, which is C34 here, which goes to ground. Come up here, C37. Okay, hold on. Let's see. This one, C37. Okay, so that's this one down here, which now has a 0.05 because they changed it. This, I told you this wasn't original. So it's supposed to be a 0.01 to ground, and this is ground. This is ground, grounded to the pin here, and to the socket. So that's ground. So they put this in. They replaced this resistor, which was a 1000 ohm, 1 watt or half watt, with this 470 ohm 2 watt, which could have fried that coil. And then they put in this 0.05 600 volt Sprague to ground off of it, and that's correct. It's a 0.05, so the Sprague is fine. It was added later. Of course, it's no good now, and that's why you can see it's got this knob here. Apparently, they just soldered it to this, the lead. They soldered this wire to the lead of this capacitor. It's probably something they had in their junk drawer, and put it in. You know, the fact that this burnt up means something was wrong. You don't drop the resistance and increase the wattage so you can send more power through it so it won't burn up. That's just dumb. So this needs to be replaced back with a 1000 microfarad. If there's a problem that burnt it up, then you got to figure out what that problem is. Most likely the problem was this capacitor was shorted. And when it went shorted, it connected this 1000 ohm resistor right to ground. And of course that would burn it up, right? All the current, because this is on the main, it's on the main line coming off the B+. So it was B+ was going right from here to ground. But we're going to change that. We're going to take that stupid thing out. I'm going to leave it there for right now, but because I'm sure it worked when they put it in there, or they wouldn't have left it there. Well, at least I hope that's the case. But either way, it's going to be dropped down to 1000 ohms because that's what the schematic calls for. So that's why you got to have a schematic, and you got to find, anytime anybody's worked on something like this, you got to figure out what's going on. So the next thing is this here. Is this the right value? This is a brown, black, yellow, so it's a 100K ohm, and they're going from, what pin is that? What a socket, that's the broken one. Okay, so this is 8, they're going from pin 8 to pin 6. I'm assuming pin 8 is grounded, I would imagine. Yeah, I would imagine pin 8 is grounded. Can't tell for sure. It's connecting to 7, 8, and 1 are all connected together. So it's going from pin 6 to 7, 8, and 1. And it's all 100K. Let's see if we got that on that tube. And according to that, that would be the output amp, 6V6. So do we have 1,000 ohm to ground? No, I don't see no 1,000 ohm to ground. I mean 100K. Yeah, right here, 100K. I take it back. R51. And there's a capacitor, a 0.05 capacitor across it. And do we have a capacitor across it? We have this one that is floating and dangling. It's across it. And we got this joker. Yeah, this is a 0.5, gigantic 0.5. I don't know if that's going to ground. But we're supposed to have a, yeah, that's a 0.5. So yeah, that's probably it. Wow, let's see if that's the right one. That would be this big C54. Is that what it is? Yes, C54. Okay, so that's going to ground. So that resistor is correct. This 100K that they got dangling over here is correct. Apparently one burnt up, and they put that one in, and you see how they did it. And it was shorting, almost shorting to the chassis there. And it was shorting to the chassis on the wrong, to ground, when it's supposed to go through this capacitor to ground. So that's a problem, right? What else can we find that is quirky here? Well, the rest of it is just bad solder joints and stuff. I don't see anything else. It looks like it was replaced. But this resistor, this capacitor, and this resistor, I don't see anything else. So maybe we'll luck out and it'll be okay. But I still can't power it up. I was incorrect. The tube that's burnt out is the amplifier tube. It's this one here. The tube that I got in is the rectifier, because the original rectifier was weakened by this audio amp tube. And this was bad because the key is broke off, so somebody stuck the tube in the wrong way. I hope it ain't the same guy who was working on the radio that broke that off, because that was a problem. Oh, this was the other thing, right? Where was that? There was this goofy lobe sticking out. Okay, that would be the old resistor. I knew it was part of a component. You see how it's like, let me see if I can bend it up a little. See how it's kind of like bell shaped? Yeah. My camera will focus. See it there? This wire, how it's kind of bell shaped. That's the part that was inside of the resistor case, and this is the lead that came out. So we have the lead here, and the part that was in the resistor right there. And so that blew out just like this blew off. And so they went ahead and put this one on, and they left that there. Well, why would you leave that there on the output tube to pick up noise? I mean, that's the output tube. You don't want an antenna on there. Let's get that off there while we can, because we don't want it there. Okay, that's gone. I don't see any other funkiness other than they redid this for some reason and resoldered it. Amazing. It's amazing what you find. Okay, so get that out of there. See, that's part of the lead. You see that? Get it in my hand, maybe you can see it better. That's kind of cool. That's the part that connects to the inside of the resistor in this case. And you can see it got hot too. You just blew that resistor right to smithereens. And the other half of it isn't even there. But I can't believe they left that there. Now this thing, it won't reach there because they shortened the wire. I don't know why they messed around with that. And they took it off. Oh, look at that. They took it off and then they spliced it in there. And as a result, they yanked this out of here. Boy, I hope that's right. So we'll have to check some of these capacitors, these micro capacitors as we go along too. Anyway, as soon as I get that other tube in, we can do a test. I can't do nothing without a tube because it's not going to do anything. It's not even going to power up without an audio output tube. And The rest of it, I'm thinking looks okay. I might go ahead and put this back to 1,000 ohms before I even go any further, because I don't want that 470 there. I don't want to take a risk of hurting that IF can if they haven't heard it already. And it may be right. I mean, maybe what they did was okay. The possibility is when this shorted the ground, it could have hurt the transformer coil, and the only way to save it was to drop the resistance. But that's really fluky to do something like that. So rather than believe that that's the case, I'm going to disconnect this, and I'm going to put 1,000 ohm back in there where it belongs, and it's going to be what it was. A half watt. I ain't putting no, I might put a 1 watt, but it's going to be 1,000 ohms. It's going to be the resistance that it calls for, not half of it. That's not even half. That's less than 500 ohms. Let's see if it's even any good. While we're looking at it, we might as well check it, right? Because it's possible that it got hot and changed value. So let's see what we get across this meter. Well, no, it's right on the money, pretty much. It's half of the value it's supposed to be. 501 ohms is supposed to be 470 plus or minus 5%. So that would be, for 500, 5% would be 20. That's silver, isn't it? Yeah, that's silver. That's not white. Oh. So that's 10%. Yeah, 10%. So 10% on 500 would be 50. So it's within 50, which means it didn't go out of tolerance. Let's check a couple other weird ones, like this one here that's just flopping around. It's supposed to be 100K, and it's fine. I say it's fine. It's charging a capacitor that's across it. Okay, as soon as it's done charging it. Okay, so it's 100 and looks like around 107, 108K. As soon as that capacitor fully charges. The reason it's taking forever is capacitors are short. So charging that capacitor should be instantaneous, practically, but nope, it's taking forever. So, okay, so the capacitor is not really charging all the way up very fast. Time constant's really high. Okay, looks like it's getting there. It's still climbing, ain't that something? I think it's about done. So I'll figure 110 ohms. But that's it. I don't think it's going to get to 110. It's 109. So we'll say 110. It's 100 plus or minus 20%, so it's good, because it would be good up to 120. Actually 10%. It'd be good up to 110 as it's silver band tolerance. So that means that it's right at the very top of its allowable amount, but it's still good. Let's most of these, you notice, don't have a silver band. See these? That's how one other way to know that they changed something. Now some of them may have. That's an original. That might be original because it's got a wide band. It's not like these. And see how narrow that one is. These are added later. Let's try this 303.3K. 33K, yeah, with 33K. What was I thinking? Okay, so it's 29K. It's fine because it's plus or minus 20%. So it's not even, it's 10%, right? It's close enough. Here's another one, same value. Let's see what we get here. Okay, that one's a little high, but again, not bad. It's charging a capacitor though. Trying to. Okay, so that one's 40K. That's pushing it. Let's see what the top level would be. And this is how you check these things. It was 33K plus 20% would be the top max, because it's plus or minus. I'll try that again. 33K plus 20% equals, I was right, 39.6. So you see it's bad. It's 40.3. Now, it could be because the tube's still in the socket and there's a cross it or something, you know. We go cut one lead, we might find out that and test it again that it is actually intolerance and it's just some resistance across it. Or it could be this big old globby solder joint. It's not a good solder joint causing some resistance. in series with it, but more likely it's the two. That does look like it was added. Here's a little guy, and it looks like a 3.3 meg. Let's see what he's measuring. He's doing pretty good, I would say. Look at that. He's going to stop right around 3.3. I mean, a little more maybe. But geez, that's amazing for a plus or minus 20%. That guy's right on the money. Okay. I don't see any other suspicious looking things. Here's a 6.8K. A meg, I'm sorry, 6.8 meg. See if I can get on there. That's not good. That's not good. 6, 8, and 5 zeros. Yeah, that would be 6.8. He's out to lunch. That's why you gotta check these. Yeah, that's really bad. From 6 meg to, that's 33K. What the? 6, 8, and 5 zeros. There's something across that joker that's pulling it way down. It's not even, that's a capacitor. Another. Yeah. I don't know what's pulling him way down. But something's pulling. It could be a shorted capacitor. Yeah, it's possible it's across this one. No, that's a resistor. That's weird. Okay, let's check that one. That one is 210 ohm. Why am I getting 33K on these? Hold on. 34K. What the heck is going on there? Let's go back to this one. We know what it is. It's 500. Oh, 501. Yeah. Why is this joker up to 33K? Whoa. 211. 210. And this one's registering 33K. Are they across each other? Ah, they must be across each other to a shorted capacitor. Yeah, see, I'm getting the same value on both. 33.8K. Come up here, it's going to be roughly the same. Yeah, there's the short. There's the short. So, one of these capacitors is short, see, 33K. One of these jokers. Okay, this one goes here. It goes to this green wire. And where's the other side of that go? Oh, that black wire goes here. Goes through this 33K. See it there? That's 33K. And we checked that. And if this is shorted, well, that's connected here. No, that's not the problem. This one here, this one's bad. There's no way this could be a register in 33K. That's 210, so this resistor is open. Because I'm not on the right wire. No, I'm saying 33K. I'm going to disconnect this and take a look at that resistor. Okay, that joker is bad, bad, bad. 34K across it, and you see it's orange, red. That could be red, orange, brown, but it's sure not red, orange, orange. Those are orange. See, that's orange in there. 33K. This isn't no 33K. If it is, it got hot and the color just faded away. That's just weird. And so this one, let's see if we get 460 on this one now. 4.8K. Meg. It's meg. Oh, meg. It's the green. 6.8 meg. That's what it should be. And no, yes, it's going up. Okay, so it's charging a capacitor. It probably is good. And it was this one, the other side of this, is probably through a shorted capacitor or something and jumping across that. Another thing, when I unsoldered this, like I said, somebody's been in here and did all kinds of stuff. When I unsoldered it, it just came off. It was not, you see it barely even reaches there. It was just like that. Is that something? If that was like that. Look at that. I mean, it just barely reaches. You forget about hooking on, it just barely reaches. Don't even need this insulation because it ain't reaching it anyway. So I'm going to go ahead and tack it back, but I need to see what it's supposed to be. Anyway, I'm going to stop at this point until I get the other tube I need. There's nothing else I can do. Thanks for watching.